Day 2, Problem 1. Part A, identify the slope and y-intercept for the graph of this equation. Now, this equation is in a certain format. The letter y is alone to the left side of the equal symbol. Following the equal symbol is the x term, and following the x term is the constant term. Okay? And when an equation is in that form, it's very fast to find the slope and the y-intercept. Here's the equation, and the number that's in front of x, called its coefficient, that is the number that's being multiplied to x, is the slope. And so the slope of the equation is -4. And the y-intercept is equally fast to figure out when an equation is in this form. The constant number is the y-intercept. And so the y-intercept is +5. The slope is -4 and the y-intercept is +5. Now in Part B, we can graph the equation using those two facts that we just figured out, starting with the y-intercept. The y-intercept is +5. There is a dot on the y-axis at +5. So from the origin, just coming up to where +5 is, this dot is called the y-intercept. We can use the slope, which is also called rate of change, to find another dot on the line. Now if the slope is -4, what that means is that the y value is decreasing by 4 units each time the x value increases by 1 unit. Of the number -4, if you write it as a ratio, would be written as -4/1. The y value will decrease by 4 when the x value increases by 1. So let's do that on the grid. Starting at the dot, let's increase x by 1 spot to the right, and decrease y by 4. 1, 2, 3, 4 spots down. Here is another dot on the line that is the graph of this equation. We could do this again. Increase x by 1 and decrease y by 4. 1, 2, 3, 4. So here is another dot on the line that is the graph of this equation. And carefully we draw a straight line through the dots. And that is Part B, the graph of the equation. Now, Day 2, Problem 2. The table shows how much grain is stored in a farm's silo. Assume the relationship between the quantities is linear. Find and interpret the rate of change and initial value. So for rate of change, we're going to examine from row to row and figure out how is the value of y changing as the value of x changes. It doesn't matter which rows we look at. For instance, we could look at this row and this row. So from 10 to 11, the x has increased by 1 unit. And while that happened, the y has gone from 14 to 8. It has decreased 6 units. And that comparison is called rate of change. So rate of change, the y has decreased 6 tons while 1 month has gone by. Another way to write this is -6 tons per month. Now the other question we're asked to determine is the initial value. How much grain is in the farm's silo to begin with? As time is going by, less and less grain remains in the silo. It's being used perhaps to feed the animals, or perhaps it's being sold, and so the silo is getting emptier and emptier as time goes by. But how much grain was in the silo to begin with when X was 0? That means we're going to need to back up in the table from 9 to 8 to 7 to 6 and so on all the way back to 0. Now, how many months back is that? If the first row of the table is at the 9th month, and we want to go all the way back to the 0 month, we need to back up 9 months. Now, the rate of change is that the silo is decreasing 6 tons each month. We want to back up 9 months. So let's take the information from our first row of the table. At the 9th month, there is 20 tons of grain in the silo, and add back 9 months worth of our rate of change, 6 tons per month. 9 times 6 is 54, so 20 plus 54 is 74 tons. In the 9th month, there was 20 tons of grain left in the silo. But going back in time to the start, there were 71 tons of grain in the silo, and that is its initial value.